Hope you're well. Lesson 6, the ready and the set and the go. Let's talk about it. Starting out with a pretty basic factoring. X squared minus 2x minus 15. You're looking for factors of negative 15 that add up to what kind of 2? Negative 2. So our factors here would be negative 5 and 3. Our a term for x squared is just 1. So this is a pretty simple rewrite to just x minus 5, parentheses, x plus trace. You can apply the zero product property and say that if this all goes to 0, x minus 5 could be equal to 0, or x plus trace could be equal to 0. So this will occur when x equals 5 or x equals negative 3. Each h of 0, pretty quick plug and chug. Your y-intercept's now 0, negative 15. I'm going to start to graph some of these points too. This is an interesting way that they're pretty much saying, hey, start graphing them based off of some points or some ideas that you have already built up. So negative 3, comma 0 is fair game, and also 5, comma 0. That's fair game as well. And we also have a y-intercept of negative 15. Wouldn't connect it just yet because we don't know if this is our lowest point, but we can just hold on to it. At a quick glance, we know that in between our two x-intercepts, there should be our vertex and our axis of symmetry. So where do you think our axis of symmetry is going to be? Well, if you measure this out, there's a difference of 8. And if we split that in half, we're going to have our axis of symmetry where x equals 1, because it's the halfway point between those x-intercepts. Capiche? So somewhere when x is 1, we'll have a y-coordinate, and that y-coordinate we're going to put in some work and find real quick. I'll give you a moment, actually. Try and find that on your own. So hopefully you were saying that your lowest value, the minimum, is going to occur at 1, negative 16. So we see that our vertex is here. I feel as if this is a pretty good review of what you've done before with quadratics, graphing them out using x-intercepts. Hope that example was helpful to you. 4 is going to be a little challenging, but it's nothing you can't handle because really, I mean, look at this closely. Isn't this kind of like a difference of something? The difference of squares. So really, we could rewrite this as square root of 9, which is 3, minus our next term, which in this case is x, interestingly enough, and 3 plus a version of x. If you saw this and your inclination was to rewrite it as negative x squared plus 9, totally works. That actually will help you when you deal with the graphing. This is now going to kick back roots of x plus or minus 3. Our y-intercept is going to be 9. And our minimum value is actually not going to exist. So here I'm going to say donut or DNE. Because this is going to go down like Tuesday. Or actually, I don't know. Think of a song where something goes down. Oh, meet me in the club. It's going down. All right. So it's going down. So as a quick sketch, our y-intercept's 9. And this just keeps going down and about. Changes of 1 and 1 on both sides, and then 3. Then it's going to shoot to 5. We see our x-intercepts occur here. So this all just kind of makes sense. If you saw this and it looked a little intimidating, I would agree with you, but don't let it throw you down too much. You got this. Okay, I'll see you in the set. For the classwork in 3.6, can't believe we made it this far. That's crazy. You were asked to talk about some statements and decide on if they're true, always true, sometimes true. So I'm going to give you a moment. Think of some examples. I'm going to definitely talk about 8, 10, and 12. So maybe think these out on your own and see if it matches with what I'm going to say. Maybe think of an example that works for that too. I hope you had a good time coming up with some examples. 8's false because think of any linear equations. If you multiply them out, you're most likely going to have a cubic function, and that's definitely not linear. Sorry, quadratic function, and that's definitely not linear. Set of cubic polynomials closed under subtraction is sometimes true because if you have cancellation of your cubic term, it's not cubic. But if you have a leftover cubic term, then it's going to probably stay cubic. Sound good? 12 is never, because you might get a situation like this. You have a dividend that could be factored, but your divisor, it's just not that factor. So then that leaves you a remainder and it gets dicey at that point, and we just say, no, it's not going to happen. So I hope that helps for there. Solve each quadratic equation by factoring. Some of these are going to be pretty simple factors of the constant that match up to the sum. Some you're going to have to put in a little bit of work with quadratic formula. So I will hand that off to you now. Just like that ice cream jingle, x equals negative b plus or minus square root b squared minus 4 ac all over 2a. I love singing by myself. That was really fun. So, I mean, 13 you could factor pretty easily. 14, I think you can factor pretty easily. So I'm going to give you a chance to try the following. Try 13, try 15, try 17, okay? Pause the video, try them. So there's a lot of work here. Let's break it down. 13 is a pretty yeah, it's simple. So simple. Yeah, Mr. Cortez, it's so simple. You can move the 33 over. You can think of factors of negative 33 that add up to negative 8. It's going to be negative 11 and 3. So this is a pretty simple factoring. Set these equal to 0, or just think opposites of negative 11 and opposites of positive 3. So your answers are negative 3 or 11. 15, you can try and try, but you can't really think of factors of negative 74 that add up to negative 2. So use quadratic formula. You're going to burn through a little bit of arithmetic. Luckily, this radical is pretty simple to simplify. Factoring out 100, square root of 100 is 10. So 10 times square root of 3, all of that over 2. Notice how I'm using opposite of b out here. And I'm squaring this b to make it positive 4. And that, to me, that arithmetic's not too bad. I don't actually need this division by 2 down here. So there you go. X equals plus or minus 5 times the square root of 3. 17 can be factored. Put in a little bit of work. Think out. 8 times c is here. So 2 times that negative 4 gets you negative 8. You're thinking factors of negative 7. It's going to be negative 8 and 1. You can use factoring by grouping. Factor out 2x, factor out 1. You can then solve these and say that x is negative 1/2 or 4. Capiche? I think that's it. I didn't think this Ready, Set, Go was too bad. If you have any questions, reach out. Take care. Brush your hair.